Hello, Zach with Slate Robotics here. I got a question over the weekend. So, what can the TR2 actually do? I've seen some videos on social media. I've seen some videos of it moving around. I haven't yet seen it in any sort of like application type of setting, right? Like I haven't seen it yet. The example that he used was make a cup of coffee. You know, he's wanting to know if this is capable of making a cup of coffee. He wanted to know if it's capable of operating a 3D printer. Now, the difficulty with answering any question like that and giving a simple, concise answer is that, well, first of all, I haven't tried the cup of coffee thing. I haven't tried operating a 3D printer. And also, you know, there's not these aren't like measurable kind of, I can't give like a general answer to that. I can either tell you I've tried it and it worked well, I've tried it and it hasn't worked well, you know, I haven't tried it at all. So those are the kind of answers I can give to the application specific questions. So if you're wondering to know what can the TR2 do, this video is an attempt to give kind of a broad answer and tell you kind of where we're at right now. So with most applications, you know, we haven't, you know, with that kind of stuff, like applying it to, you know, we're going to make a cup of coffee, we're going to operate a 3D printer. With different tasks, there's a certain level of precision that you need, you know, and there's some tasks where you don't need very high levels of precision at all, you know. That was one of the things that I noticed early on is, you know, there's so many tasks that you can, you know, potentially where a robot could be applied in some sort of setting, and, you know, the fact that it doesn't have incredibly high precision doesn't matter at all. You know, if you're going to drive around and you're going to pick up dirty clothes off the floor, for instance, and you just need to put them in a basket, you know, you can imagine a shirt laying on the ground, you know, takes up an area this big. So really, in theory, the robot only needs to be able to, you know, measure for the center, and it has this whole margin of error around the outside. And then same with the basket, right? So there's so much. It doesn't need a super high level of precision in order to do that kind of stuff. So I noticed early on that even you can get a lot of value out of even the low level or low precision types of tasks. Now, if you move on up the scale, you know, maybe making a cup of coffee is kind of in the middle of like really low level of precision. You know, low level being picking up clothes, middle of the road being making a cup of coffee. You know, like with a Keurig, for example, you just need to lift it up. You need to push the button. You need to grab the K-cup, and it has to slide in just the right way. That's probably the most challenging part. And then close the lid, push the button, grab the cup of coffee. That's, you know, there's nothing too crazy about that. And then I would put operating a 3D printer on the further on the more precise end. This gets to the kind of the second part of what makes this a difficult question to answer. If your idea of the robot operating a 3D printer being grabbing your little scraper thing and, you know, physically wedging underneath the print and shimmying around and, you know, plopping it off the print like that, that requires a great deal of precision. That requires a lot of precision. If your idea of operating a 3D printer is the robot reaches in, you know, to that little dial on the front, turns it just the right way for the, you know, so that it changes the setting on that menu to, you know, SD card, and then clicks, and then changes it to print, you know, start print, and clicks again. That requires a great deal of precision. But the nice thing is, with all of these systems, you can design the system itself as a whole that doesn't require the platform itself to have that high of degree of precision. An example of that is when, you know, and this is oftentimes what you see, is you have like removable trays or something that act as the bed on the printer. Or you have those magnetic printer beds where all you have to do is just go grab the bed, pull it off, and put it in a pile. And that is certainly a task that the TR2 can perform. I mean, that is That's just a matter of reaching in, grabbing the print bed, the removable print bed with the print still on it, yank it off, go over there. Other examples are you can use Octoprint or some sort of I guess remote printer software. You can integrate that with whatever program you have running on the TR2, and you can have that program over some sort of wireless communication start and stop prints using API calls and stuff like that, rather than requiring some incredibly high level of precision to actually manually operate the controls. So with most of these questions, the answer is yes, the TR2 can perform that task, but it depends on what you mean. There might have to be, for the more precise end of the scale, you're probably going to have to figure out how to design some sort of system to make the robot have an easier time with it. So this is the kind of so that kind of gives you a better idea of what the TR2 is capable of. If you work with the TR2 and you go into it, I'm going to show you an example of where the hardware is at right now and where the kinds of tasks that this thing can perform reliably. I've got a simple example where we'll pick up a stepper motor, we'll move it to this box, and we'll go ahead and run through that and show you. That's a simple task that the TR2 can do well and can do repeatably. And given this level of precision, I'll also talk about the kinds of things that we're working on that are going to improve it, even if you bought one today, because we're making software improvements that are going to increase the level of precision. Even if you bought one today and it can only do this kind of stuff, there's still so much you can accomplish with that if you work with the system a little bit. So let's go ahead and dive into that. I'll show you a quick demonstration of this platform. So release the actuators. So now I press start, make sure our stepper motor is in the right position. TR2 is going to, so these are all positions that I've recorded with an Xbox controller, and moving, it's waypoint recording, so we're moving it from one position to another, and we're recording certain positions, and then we're just doing playback. So we're just going through those settings. It's waiting to see until it reaches that position to move on to the next waypoint. There we go. And right now this thing just kind of drops it in the bucket right there. It doesn't. The gripper's a little bit too wide for this container to be able to lay it gently in there. But so that's an example of, and maybe you can see, maybe you can't see very well, but the stepper motor ended up in here. And that's a task that this thing can perform, pretty repeatably, pretty well. We also have the problem of I picked this up and now I need to find that position that it was at just a second ago. But working with blocks, working with things that are, there's a lot of margin of error here with picking up this gripper. So these are the kinds of tasks where you're going to have a really good time applying the TR2 in those kinds of settings and building applications around those kinds of tasks. And looks like, I'm not sure if, okay, yeah, no, we're fine. And it drops off the servo. And so all of this code, so I didn't build an actual application for what you just saw there. I didn't go in and program something specific for picking this up, dropping it in here. This is all just a general purpose application that I built where you can record positions and do position playback. This is currently a part of the TR2 Xbox teleop demonstration that takes some of these commands and records positions, writes them to file, that kind of thing. So, that's open source. You can go check out that on our GitHub. But this was something that the TR2 can easily perform. Pick up a block, move it over here. This is a NEMA 23 stepper motor to give you roughly the idea of the size. Pick it up, move it over to here, drop it in this bucket, and do that over and over again, no problem. Pre-recorded positions, that kind of thing. We haven't integrated the camera or vision system or anything like that into this application. We're not doing any machine learning or anything like that. But what is the TR2 capable of? What's the kind of thing that I can guarantee? I can absolutely guarantee at the low level, what can the TR2 perform? Well, these kinds of tasks, just like you've seen. I can guarantee that it can pick up the stepper motor, move it over, and put it in a box, and it can do that pretty repeatably. I can't guarantee, but I can, what's a softer word than guarantee? I can just about promise that there's so many software improvements that we're going to continue to implement and build out over the coming weeks, coming months, that are going to improve the precision of the controllers, that are going to improve the repeatability. It's going to improve different calibration routines to ensure that it's always that these are the kinds of things that we're working on the software side that are going to even more greatly improve how well this thing performs. One example of that is that this is just angle recording and playback of each of these joints. That's really the wrong way to do it. What you should do, and what we will do, is you should do trajectory planning, so that you plan the path of the end effector from here to here, so that the end effector follows the path you want it to follow. The problem that can happen with recording and playback of just the angles, which is the easiest way to do it, is that there's no guarantee that the end effector follows the path that you want it to follow. So if you want it to approach with this particular position into the box, there's no guarantee, and you have to make sure that you record the angles properly. But this is just simple integration with ROS that we've done with our TR1 platform, and that has all of that built in. So that's one example of a really big improvement that you can pretty much count on. But anyway, I hope this gives you a better idea of what the TR2 is currently capable of. And again, most of your questions, can it do this? Can it do that? Well, yes, if you work with it. And secondly, I don't know. I can't guarantee 100% that it can perform some tasks just like you perform a task. That's obviously the direction we're wanting to go, and that's when you buy a TR2, that's what you're enabling us to do. You're giving us the opportunity to work with you. You're giving us the opportunity to continue to improve the product, improve the features, and come out with better products and better features down the road. You're helping fund us by ordering your robot and by playing a part in this personal robotic revolution that we're starting. So that's pretty much all I've got for you. Thanks a lot for watching. Comments in the description, or comments below if you have any questions. Email me, zach@slaterobots.com. You can go to our website and leave a question on the forums or anything like that. Just contact me in any way possible with your questions. I'd be more than happy to help you out and help answer those. And as always, thanks for watching. You guys have a great day.